in previous video, you have studied about the salt, the compound produced by chloralkali process, that is electrolysis of sodium chloride. Next, we have to study here the other compounds obtained from sodium chloride, like sodium bicarbonate, that is the baking soda, and sodium carbonate, which is for the washing soda. Now, what is baking soda? Now, the next heading is baking soda, that is the next compound obtained from the raw material common salt, that is sodium chloride. Baking soda, the formula for it is NaHCO3, that is its chemical name is sodium hydrogen carbonate, or we can also say sodium bicarbonate, sodium hydrogen carbonate or sodium bicarbonate. Now, it is mild alkaline in nature. Now, student, we see that is here there is the presence of H, means it contains ionizable hydrogen atom. But so it is an acid salt. But since in the formation of this salt, this compound, sodium hydroxide is used, that is the strong alkali. So it will be alkaline in nature. Its aqueous solution will be alkaline in nature. Now, how is the washing soda or baking soda prepared? So industrially it is prepared by solvay process. Also known as ammonia soda process. Now we see that what are the different compounds used in it, what are the raw materials used in it. Now the raw materials are NaCl, that is the common salt. Now second, ammonia. Third, carbon dioxide, that will be from limestone, that is calcium carbonate. Now, how is it prepared? We see here that is, first of all, we pass ammonia gas through aqueous solution of sodium chloride, and then carbon dioxide is passed through it. So, what will be the reaction here? NaCl plus H2O plus ammonia, and then carbon dioxide is passed through it. As a result, the products are ammonium chloride and NaHCO3. Now, so from this solution we obtain sodium bicarbonate, that is the baking soda. Now, when this baking soda is heated, it decomposes to give sodium carbonate and carbon dioxide along with water molecule. So now we see that here on heating NaHCO3, that is the washing soda, we obtain Na2CO3, like you see, that is NaHCO3 on heating gives Na2CO3 plus H2O plus CO2. So this process is known as solvay process or ammonia soda process. Now, students, we see here that is, this is the industrial process. Now we have to study its different usage. The most important application of this one is in preparation of baking powder. As the name suggests, that is, it is baking soda, that is it is used in preparing, that is making the dough fluffy, like in making pakora, bread, biscuits, cakes. We use this one because when this baking soda is heated, carbon dioxide is evolved that makes the dough fluffy. So it is used in making preparation of baking powder. Now what is it? Baking powder, it is not the baking soda. Normally we see that when this is heated, sodium carbonate is produced. Sodium carbonate makes or gives bitter taste to the edible items due to the formation of sodium carbonate. But when it is mixed with, that is, it is baking powder is the mixture of baking soda, that is NaHCO3, and mild edible acid like tartaric acid. So this tartaric acid neutralizes the bitterness caused due to sodium carbonate. Like you see, suppose we have NaHCO3, sodium bicarbonate. Now it is heated. Here we see that in normal condition, like you see, suppose it is heated, it gives us sodium carbonate plus H2O plus CO2. CO2 will make the dough fluffy, but sodium carbonate formed will cause bitterness. So when it is reacted with this type of acid, any acid, then it gives us that is H2O plus CO2 causing duff to be fluffy, plus sodium salt of acid. As a result, now it will be used for making the pakora, biscuits, cakes, and anything in which the dough has to be made fluffy, spongy. Clear, student? So here you see, that is, we write here sodium carbonate formed by heating NaHCO3 gives bitter taste, but tartaric acid or any other acid neutralizes its bitterness. So this is called baking soda, and then the baking powder. Now next use of it is, that is, here sodium bicarbonate is used. It is used in making washing soda. Now it is used for making, that is, it is used for making soap and detergents, etc. So these are some of the important uses of baking soda, that is sodium bicarbonate. Again remember, it is mild alkaline in nature due to the use of a strong alkali NaOH in its formation. Clear, student? So this is baking soda. Students, sodium bicarbonate or sodium hydrogen carbonate is also used in fire extinguisher, that is called soda acid fire extinguisher. Now, the next topic is washing soda. Washing soda. Now, the washing soda is Na2CO3 dot 10H2O. Now, how is it prepared? That is, it is in continuation with the preparation of sodium bicarbonate, it is obtained. Like you see, first of all, that is the process is, again, the solvent process is in continuity. Like you see, NaHCO3, sodium bicarbonate, prepared in solvent process, is then heated. It gives us Na2CO3 plus H2O plus CO2. Now, when sodium carbonate is recrystallized, that is recrystallization of Na2CO3 gives washing soda. Washing soda. Like you see, Na2CO3 plus 10H2O. On crystallization of this solution, it gives Na2CO3 dot 10H2O. Now, what is the 10H2O is known as? This is called water of crystallization. Water of crystallization. Now, this washing soda is also mild alkaline in nature. Now, so we have obtained washing soda, baking soda, and all of them were obtained from normal common salt, that is sodium chloride. Now, what are the different uses of washing soda? Now, first, in preparation of soap, detergent, paper industry, borax, etc. First thing. Second, it is used in, that is, in cleansing, in households, or houses, we can write directly, in houses, in cleaning in houses. Now, it is an important, that is both of them, washing soda as well as baking soda, are important industrial raw materials, reagents. They are also used in laboratory. So, in preparation of many industrial substances. So, these were the different uses and method of preparation of baking soda and washing soda. Clear, student? Now, here we have to start with the water of crystallization. Because the salts, the crystalline salts, are they actually dry, or are the all salts actually dry? No, some salts contain certain fixed amount of water molecule attached with their molecule, which on just mild heating they are vaporized, leaving behind only the compound molecule of the compound. Here, like you see, suppose washing soda is heated, 10H2O will come out and only Na2CO3 will be left behind. That is also known as soda ash. So, the next topic which we have to study here is, that is called water of crystallization. The heading is water of crystallization. Water of crystallization. Just we have studied, that is the fixed number of water molecules, which enter into enter into loose chemical combination with each molecule of a salt when it crystallize out from salt solution is called water of crystallization. So all the salts are not actually dry. For example, suppose if we take Na2CO3 like that of washing soda, Na2CO3 dot 10H2O, it is heated. This water molecule is attached with it. It was attached during the formation of crystal. So it will be 10H2O vaporizing first, and we will have only dry Na2CO3, that is commonly known as soda ash. Now water vapor will come out. Second, suppose we take an experiment, that is action of heat on blue vitriol. Blue vitriol is CuSO4.5H2O. Now suppose we take blue vitriol crystal in a test tube, hold it with the help of holder. Now it is then heated over a burner. This was initially blue crystal. When it is heated, then we see that vapors come out of it, and on its cooler part the liquid droplets get deposited. After that, here the white residue will be left behind, that is CuSO4.5H2O. When heated, here it is blue crystal. When heated, it is CuSO4.5H2O, that is the vapor will come out that condense on cooler part in the form of colorless liquid droplets, and here white powder is left behind. If we will again add water to it, that liquid molecule will be again added to it. It will again regain its color and crystalline nature. Means the water of crystallization is responsible for is responsible for the color and crystalline nature of the salt. Means when there was water of crystallization, it is called hydrated copper sulfate. It is blue in color, it is crystalline in nature, but when heated, when it loses water of crystallization, it becomes anhydrous copper sulfate, which is white, that is not blue. It has lost its color, as well as it has lost its crystalline nature, and it has turned to powder form. So what do you observe here? That is when CuSO4.5H2O is heated, the colorless liquid droplets, that is water, condenses on cooler part of test tube, and white powder is left behind. White powder is left behind. So here we see a student, that is, from where does the water molecule come? It must have come from the blue crystal, that is the copper sulfate, hydrated copper sulfate. So this type of water molecule attached to a salt is known as water of crystallization. It means that all the salts are not perfectly dry. Crystals containing water of crystallization will have water molecule which on heating gets evaporated, leaving behind anhydrous salt. Clear, student? Now, we take another example of it, that is plaster of Paris. Now, the next one is plaster of Paris. Plaster of Paris, that is CaSO4 dot half H2O, that is chemically it is called calcium sulfate hemihydrate. Hemi means half, hydrate means water. Now question arises that the molecule, half molecule is not possible to obtain. But in general it is written like that because the two formula units of calcium sulfate get attached with one water molecule. So in general it exists like that. But for one calcium sulfate, there will be only half H2O. So plaster of Paris can also be written like that. That is calcium sulfate hemihydrate. Now we see, a student, how is it prepared? So on heating gypsum, that is CaSO4 dot 2H2O, we obtain plaster of Paris. That is, when this molecule CaSO4 dot 2H2O is heated at 373 Kelvin, that is at about 100 degrees Celsius, then it loses 1.5 water molecule, 1.5 water molecule per molecule of gypsum, and then this compound is formed. This is white powder. Gypsum is used in cement industry. Plaster of Paris is white powder. Now, when this plaster of Paris, which is white powder, is again added with water, mixed with water, then on drying it again becomes hard. Now, this fine powder finds its many uses. Like you see, first, doctors use it for plastering the broken bones. Now what happens to it? Actually, a layer of plaster of Paris along with cotton is wrapped over the part of the body inside which there is a broken bone. Now when it gets dried, that is the mixture of plaster of Paris and water in the form of paste along with cotton is wrapped over it. When it dries, then it becomes hard and gives harder support such that the broken bones cannot be dislocated. It remains static, and as a result healing process becomes faster. So it is used by, that is we can write here, in short it is also written as POP, plaster of Paris, when mixed with water and on drying changes to changes to hard gypsum. That is, again it becomes gypsum. So again similar reverse reaction takes place. Now second, it is used in making toys, statues for, as well as for making smooth surfaces or walls, etc. So we find its use even in cement industry. So just you have a student studied about the different properties of salts, different characteristics of salt, as well as the compounds formed from common salt, sodium chloride, and finally the water of crystallization, the plaster of Paris. So students, you should go through the videos in sequence in systematic way, and it will make your concept clear. You will be able to answer every point of it. Clear, student? So if you like all these things, you must share, subscribe, and press bell icon to get the latest videos uploaded by you, as well as any kind of information regarding study you will be provided. Clear, student? Okay, thank you.